This is graphing proportional relationships. When two quantities are proportional, the relationship can be represented by the direct variation equation of y equals m times x, where m is our constant of proportionality. A constant of proportionality means that that number stays constant with your x and your y. It can also be referred to as the unit rate or the slope. So when we have two quantities that are proportional, we see that when we graph them, they'll make a straight line and they will always go through the origin, that 0, 0 point. When we're looking for that constant of proportionality or that unit rate or that slope, what we want to look for is the point 1 comma something. This something number right here is our constant of proportionality, our unit rate, our slope. It's basically telling us how much the line is jumping by each time. So if this was 1 comma 10, it would be 2 comma 20, 3 comma 30. It's jumping by 10 each time. So that is our constant of proportionality or our unit rate or our slope. So let's look at a proportional relationship. The cost is going to be y, and x is the number of gigabytes of data on an internet plan, and the whole thing is represented by the equation y equals 10x. So we're going to plug some points in here. So if I get 0 gigabytes of data, I plug in 0. 0 times 10 means it's going to cost me $0. Which is logical. If I'm not getting any gigabytes, I shouldn't be paying any money. If I want 1 gigabyte of data, 10 times 1, it's going to cost me $10. Or maybe I want 5 gigabytes of data. 5 times 10, it's going to cost me $50. Or maybe 7 gigabytes of data. 10 times 7, $70. Or maybe even 9 gigabytes of data. 9 times 10, $90. So basically I can graph these. I've got 0, 0. I've got 1, 10. I've got 5 cost $50. I've got 7 cost $70. And I've got 9 costs $90. So I can draw a line through these. I see that not only are they a straight line, but the line is going through the 0, 0 point, the origin point. Those two key factors are clues that this is a proportional relationship. My straight line and my line goes through the origin. So the slope here is 10. It's going up by 10. I can also look at the point 1 comma right here. 1 comma 10. That tells me that every time my points are going up by 10, so 10 is my constant of proportionality, it's my unit rate, it's $10 per gigabyte, or I can say 10 is my slope. And that 10 slope indicates that the unit cost here is $10 per gigabyte. So for each gigabyte that I want, I'm going to pay an extra $10. So that's my proportional relationship. All right, so the weight of an object on Titan, which is a moon of Saturn, is proportional to the weight of an object on Earth. The weight on Earth we're going to call x. It says an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So we want to figure out what is an equation that could represent this situation. Well, we know that it's going to be proportional. The more you weigh on Earth, the more you're going to weigh on Titan. The less you weigh on Earth, the less you're going to weigh on Titan. So we are wanting an equation in this form. Y equals mx, a direct variation equation. Now, they told us x is going to stand for the weight of our object on Earth. So x is going to be 105. And the answer we want here, when we multiply something by 105, we're getting an answer of 15. On Titan, this person who's 105 pounds only weighs 15 pounds. So we're actually searching for this number right here, our constant of proportionality. So to solve for m, I'm going to divide both sides by 105. Cancels out here. On this side, I don't get a very nice number, but I can take this fraction and I can actually just reduce it. So 15 and 105 both divide evenly by 3. So by 5. So I'm going to start there. 15 divided by 5 is 3. 105 divided by 5 is 21. And then I see, 3 and 21, they both divide by 3, so I can go a little smaller. 3 divided by 3 is 1. 21 divided by 3 is 7. And I've got my value of m, and I'm really not going to go any smaller than 1/7. So when I want to write an equation, whatever my weight is on Earth, it's going to be 1/7 times my weight on Earth, and that will help me figure out my weight on the moon of Titan. So they want to know, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, y is my weight on Titan. So I'd plug in 3.5 equals 1/7 x. Okay, so to solve for x here, I'm going to divide by 1/7. Dividing by 1/7 is actually the same thing as taking 3.5 and multiplying by the reciprocal of 1/7. So I can actually do 3.5 times 7, and I get that the weight of that piece of ice on Earth would be 24.5 pounds. So it's 7 times greater. You weigh 7 times more on Earth than you do on the moon Titan. All right, for our last example here, we're going to be comparing some proportional relationships. It says the distance, which is going to be y, that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5 times x. So x stands for the amount of seconds, and y stands for the amount of meters the ski lift has traveled. So here's our equation. So basically, this is our seconds. This is our distance the ski lift has gone. And I can see from my constant of proportionality that for every second, I'm going 2.5 meters. So 1 second, 2.5 meters. 2 seconds, 5 meters. 3 seconds, 7.5 meters. So I'm going 2.5 meters per second. That's for my 4-person ski lift. Now, this graph shows the distance of a 2-person ski lift. So in a single second, the 2-person ski lift, if I follow up here, goes 2 meters. I have 1, 2. So in 1 second, it can travel 2 meters. So the 2-person ski lift is going 2 meters per second. So they're asking me which ski lift is actually faster. This guy's a little bit faster. The 4-person ski lift. So the 4-person lift is going to move a little bit quicker. Now if we're graphing them both on the same graph, here's my 2-person lift, same as this graph right here. I just copied this one down here. I'm going to add my 4-person lift here. Well, in 1 second, if I plug in 1, I'm going to go 1 times 2.5 or 2.5 meters. If I plug in 2, in 2 seconds, I'm going to go 5 meters. In 3 seconds, I'm going to go 7.5 meters. In 4 seconds, I'm going to go 7.5. I'm going to go 10 meters. All right, so if I connect these, here is my 4-person lift. I connect these dots, I can see that the graph that's representing the 4-person lift is actually much steeper. Steeper matters in math. Steeper means it has a greater slope. It also means that because this one is steeper, the 4-person lift is faster than the 2-person lift. So when I compare the steepness in this real life situation, it's telling me the 4-person lift is going to be faster than the 2-person lift.